Now we want to take a look at zeros of polynomial functions, and we've had this definition before, but just a reminder, a zero of a function is a number c such that f of that number, when you plug that number in, you get an answer of 0. 0 is not what you get when you plug 0 in, it's what you plug in to get the 0. Okay, so I'm plugging in an x value and getting a y value of 0. Okay, that tells me if c is a real number, that my 0 is really where my x-intercept is. Okay, let's take a look at something else related to zeros, and it's called even and odd multiplicity. And it's kind of a weird definition, but we're going to simplify it here in a second. It says if x minus r to the m is a factor of a polynomial, and x minus r to the m plus 1 is not, then r is called a zero of multiplicity m of f. So really, it just means that you've simplified, you've factored out your polynomial, and you have condensed any like factors so that if you have x plus 1, you simplify it, make it x plus 1 squared. Then that exponent here is going to be the multiplicity. And the reason I'm interested in that multiplicity is because if it's an odd exponent that's on that factor, that's going to be somewhere where we're going to cross the x-axis. But if that is an even number on that factor, then I'm going to touch and turn at the x-axis. Okay, now let's take a look at two familiar graphs. X to the third, that's our cubic function. The 0 here would be 0 because that's what's going to make this function equal to 0. I said it equal to 0 solve, I get 0. Okay, and the exponent on my factor here is 3. That's odd, and it crosses through at the origin. However, on this one, we still have a 0 of 0, right? That's what makes the 0 is 0. But this time the exponent on my factor is 2, so it's going to touch and turn around there. When it hits the 0, it's not going to cross through. All right, let's take a look at a couple examples real quick. We want to find the zeros and state the multiplicity of each. Okay, so this first one, it's already nicely factored for me. So I've got this first factor, then this second factor, and this third factor. The factors are the chunks that are multiplied together. I think it's helpful to make a table like this. So the factors here, the 0 is what x you would plug in, so the factor in entirety is 0. So the answer here would be 0. The multiplicity, one more time, is the exponent that we would see on that in the factorization. It's a 1. That's telling me I cross through the x-axis at 0. X minus 8 is my next factor. Well, an 8, if I plug it in, would make that 0, so that's my 0. If I look back up here, the exponent there is 2, so that's telling me because it's even, I'm actually going to touch and turn around at 8. And then the last one is x plus 12, so that means I have a 0 at negative 12, and I should cross it. Now we're going to look more at putting this together in another video, but right here I just want to pull up my calculator, and I've put this equation in. I didn't have to multiply anything out, I just put it in like that, and I adjusted my window so that I'd make sure I'd get that negative 12, 0 to show up, and I didn't do anything else really. Alright, this is the graph I get. It's not really interesting. I can see it kind of looks like it touched and turned there. If you go to zoom and we go to something called zoom fit, that changes my y values but leaves my x's where I wanted them. Alright, and then I can see, yep, it went through there at negative 12, it crossed through at 0, and then it touched and turned here at 8. So that's pretty cool. That's what multiplicity tells me. Alright, let's take a look at this last example. They want me to find the zeros and the multiplicities. The problem is it's not in factored form. So if it's not factored, you got to do that part. So this I could do as x squared and x squared. This is a positive 9, so negative 9, negative 1. That gets me the negative 10x squared in the middle. Then this first one can break down further as the difference of squares, x plus 3, x minus 3. And then the second one also, x plus 1, x minus 1. The exponent on each of these is a 1, so the multiplicity of all my zeros is going to be 1. And the zeros would be negative 3, positive 3, negative 1, and 1. And again, all the 0 is what makes that factor equal to 0.